Hello everyone. In this video, we're going to be dealing with a polynomial system in two variables. So we have two equations and two variables, so it's hopefully solvable. But let me just clarify, we're not looking for integer solutions or any type of rational solutions necessarily. We're looking for real solutions. Okay? So I'll be presenting two methods, even though the first method may be incomplete. All right, let's start with the first method anyways. And I'm also going to show you a graph at the end, which is, I think, pretty cool. All right, x squared plus 4y equals 1 and y squared plus 6x plus 14 is equal to 0. So I noticed that in the first equation, x is quadratic. In the second one, y is quadratic. So from the first equation, I can go ahead and isolate y. Don't ask why, but you can do it. So 4y is equal to 1 minus x squared, and divide both sides by 4. You get y equals 1 minus x squared divided by 4. So we have y equals 1 minus x squared divided by 4 from the first equation, and then we're going to plug it into the second equation. Let's do it. 1 minus x squared divided by 4, and if you square it, plus 6x plus 14 equals 0. So what did I do? I used substitution to get rid of one of the variables, and I ended up with a single variable x. Once I solve for x, I can go back and substitute in this equation to find y. I could also use one of these equations, it wouldn't matter, but this one seems easier. So now you have the square of x squared, so let's go ahead and expand it. That is going to be 1 minus 2x squared plus x to the fourth divided by 16 plus 6x plus 14 is equal to 0. Great. Okay, let's go ahead and make a common denominator, or just multiply everything by 16. That makes more sense, right? When you multiply this by 16, that's going to give you 96x. Now, what is 16 times 14? You can think of it as 16 times 10, which is 160, plus 64, that's going to be 224. That's how you can mentally multiply these kinds of numbers, especially when they're small. That's equal to 0, and I get x to the fourth minus 2x squared plus 96x plus 225 equals 0. Great. Not so great, because we ended up with a quartic equation, didn't we? Well, here's the thing. I might end up finding a rational solution, right? I mean, that's a possibility, isn't it? But how do I check? There's something called rational root theorem. And this is how it works. You look at the coefficient, the constant, and then you check its factors or divisors. What numbers could divide 225? 225 is actually 15 squared, or 3 squared, 5 squared. Those are the prime factors. So it's going to have quite a few factors, like 3 times 3 equals 9 positive and 9 negative. That's a total of 18 factors. It's going to take forever to check. That's why this is not always the best method, but obviously computers can check real quick. So what do? Suppose I test x equals 3 as a potential solution. I plug in everywhere, and if I get a different, like a correct answer, that's a solution, or a negative answer, or whatever. One of these will hopefully work. But as you can see, this method is pretty painful. That's why it's the first method. That's what it means, right? So let's go ahead and take a look at the second method, which is obviously much nicer. But this is not the only way to do it, by the way. And notice that x cubed is missing. So that's a nice thing. We can actually factor our quartic. Yes, this is a quartic, right? X squared plus ax plus b, and x squared minus ax plus c. Now, why did I pick plus ax and minus ax? Because I want x cubed to disappear. So when you distribute this, you're going to get a negative ax cubed and a positive ax cubed, and that's going to disappear. And that is the only way to get x cubed. Make sense? So this reduces the number of variables. We have only 3 instead of 4. So that's an improvement. But you can also think about this. B times c is 225. So if you're hoping to get an integer factor, or coefficient, then you can kind of look at the ways you can break down 225, like 3 times 75 or 15 times 15, and then test all these out. Obviously, that's going to take a while to do. That's why we're not going to finish this up. But you could do so and see where you go from there. Make sense? Okay, I hope it does. Let's go ahead and do the following. Go with the second method. Yay. Second method rocks, don't you think? Well, you haven't seen it yet, so let me know what you think. Second method. So let's rewrite the original problem. What was it? It was x squared plus 4y is equal to 1. And then the other equation was y squared plus 6x plus 14 is equal to 0. I just don't like writing negatives. That's why I wrote the second equation like this. And this might look a little weird because why do we have 1 on the right hand side on one of the equations and 0 on the other one? Because if you write 14 on the right hand side, it's going to be negative, and this just doesn't look good to me. I don't know. It's just a personal preference. I just wanted to put everything on the same side. And also, that kind of makes the equations look different. So that's kind of like a trick. Okay? A distraction. So what do we do with this? Here's what we're going to do. We're going to go ahead and put everything on the same side here. So we're going to get x squared plus 4y minus 1 is equal to 0. And then we're just going to put this one underneath. And there's obviously a good reason why we want a negative number on the right hand side, because when you add them, they're supposed to be negative. You'll see why in a little bit, but if I add these equations up, and why am I doing that? The motivation behind it is I have the x squared and x in different equations, but I want to put them together. The only way to do that is by combining these two equations into a sum. So it's going to look like this: x squared plus 6x plus y squared plus 4y plus 13 is equal to 0. Awesome. Now see what we have. We have a positive term on the left, but if you subtract 13, you'll have a negative term on the right. And the reason for that is we are going to complete the square. Make sense? Let's see. X squared plus 6x. We're missing 9. Half of 6 squared. Remember the trick? And y squared plus 4y. We're missing a 4 because half of 4 squared is 4. And 9 plus 4 is 13. Everything checks out. We're all good to go. Make sense? I hope it does. I don't know, I keep saying it, but I just want to check with you guys how you're feeling about this. And then this can be written as a sum of two squares. And isn't that awesome? This is not by coincidence, of course. It's been arranged that way. And from here, we get a really nice expression. If the sum of two squares is equal to 0, and if a and b are real numbers, then this implies a equals 0 and b equals 0. So and is a very powerful result. And from here we get x equals -3 and y equals -2. And guess what? That's the only solution pair. Let's go ahead and take a look at the graphs. These are two parabolas, but one of them is sideways, the other one is just regular. And guess what? They intersect at a single point. And this brings us to the end of the video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. And that's going to be in 2 hours. Until then, bye-bye.